Hi guys, this is brought to you by AOHL, Academy of Higher Learning, and in our last video we talked about properties of limits. In this video we will be talking about evaluating limits. Now there are a bunch of ways of evaluating limits. There are a couple of strategies which I've listed. So the first is direct substitution, second factoring, third rationalizing the denominator or the numerator, fourth is change of variables, fifth is one-sided limits, which are helpful and used for like when solving limits of absolute functions, and the last one is finding a common denominator. So let's start with the first one, which is direct substitution. I'm not gonna write the entire thing; it takes too long. So let's do an example. So in direct substitution, what you basically do is as the name suggests, you just substitute the limit that you're trying to solve into the function. So for instance, like say we're solving limit x approaches 3 for x, we just sub 3 in for x, so it'll be 3, which means it's 3. So that's direct substitution. It's kind of straightforward. The second one is factor. This is where you factor and you try to get rid of the common denominator if you're not able to solve for the limit. So let's look at this one. Let's look at this function. So limit x approaches negative 3 for 2x squared plus 7x plus 3 all over x squared minus 9. So in this we can factor the denominator and the numerator. So say we factor x approaches negative 3. This factorizes to 2x plus 1, and second to n x plus 3, because product is 6 and the sum is 7. So 6 plus 1, 7, and yeah, 1 times 3 equals 3. So x minus 3 and x plus 3. So as you can see that we can factor the x plus 3 out. So that's gone. And then now we can like use our first strategy of direct substitution, and we can direct substitute the x values for negative 3 to solve for the limit. And if we do that, we get 2 times minus 3 plus 1 all over minus 3 minus 3, and that equals minus 5 over minus 6, and you can get rid of the minus signs, meaning 5 over 6. So those were the two examples for one was for factoring and the other one was for direct substitution, and the third one that I listed was rationalizing. So rationalizing the numerator or the denominator. So say in this first example I'm going to use rationalizing the numerator. So say we have an example, limit x approaches 0 and it's root x plus 1 minus 1 all over x. So what we can do is rationalize the top by multiplying the top by x plus 1 plus 1 all over root x plus 1 plus 1. And if we do that, we get x approaches 0, the top, the bracket, the square roots will disappear, and you will get x plus 1 minus 1, so all over x and whatever we've multiplied by, so x plus 1 plus 1. And now as you can see, we can solve for the now as you can see we can solve for the limit, because the ones cancel out, and I'll show you the steps and you will be able to see it. So and the x's will cancel out as well, so it's x over x x plus 1 plus 1, so that, so the x cancels out and we don't have like now we can solve the limits without like having it going to infinity or some random value. So it'll be 1 over x plus 1 plus 1, and if you sub in x equals 0, we'll get 1 over root 1 plus 1, and 1 over and this will be 1 over 2. So that was an example of rationalizing the numerator. So how about and for denominator it's the same step, but instead of doing it to the top like we did here, we do it to the bottom. So it's the exact same. We can use the exact same. You guys can try the exact same example, but switch the x plus 1 minus 1 with the denominator and put the x at the top and try to solve it. It will still work out the same way. So that was rationalizing, and that was step 3. And the fourth strategy is change a variable. So in this, what we do is we like pretty much let one variable equal the other one, and it basically simplifies it. So change a variable. So I'll do an example and you'll understand it that way better. So say we have we're trying to find the limit when x approaches 9 for root x cubed over root x minus 27 over, so this is one function, minus 3. As you can see, if you do direct substitution, it's not going to work out because it's going to give you a 0 at the bottom. So we can change the variable x and try to simplify it and try to factor it then. So say we let a equals root x. So if you let a equals root x, that means root x cubed will equal a cubed. And we can take the 3 out and you'll see why this is a cubed over here. So if you change it, we have to change what it approaches as well. So if x was approaching 9, then a would approach 3 because a equals root x, which is root 9, and if it's approaching root 9, this is approaching 3. So we also have to change the limits, unless you're going to switch it back, but that's one more step and it's a waste of time. So try to change the limits from the start. So say now we have a cubed minus 27 over a minus 3. Now as you know that this will factor, and if we factor this, we get a minus 3 a squared plus 3a plus 9 over a minus 3, and this factors out, and now you can use the first strategy and you guys can directly substitute 3 for a. So once you do that, you will get 3 squared plus 3 times 3 plus 9, and that equals 9 plus 9 plus 9, that's 27. That's a bad 7, but so that's 4 down. Okay, there are 2 left now. Next is one-sided limits. Now one-sided limits, like I said in the beginning, it's helpful if you're doing like if you have to solve the limits for absolute functions. One-sided. So say we have to solve limit as x approaches 2 for x minus 2 all over x minus 2. Now we know that how absolute functions are, like if you draw this like x minus 2 function, here's 2. Okay, what just happened? Say here's 2 and something like this. So if you draw the derivative of that, or the rate of change, we will find that first of all it's like a straight line, two straight lines. So this straight line is more like x, and the second straight line is more like x minus 2. So it changes. So if we were to split this up, like, wait, sorry, this is bad. So say we continue this line and that line, and this will be x plus 2 minus x plus 2, and this line will be x plus 2, but they change. So we can change that to a piecewise function and say that as limit x approaches 2 from the left, it's minus. It's minus x minus 2 over x minus 2. And this way we can cancel the denominator and numerator and use that. And now we can solve for the limit as x approaches from minus. It's minus x, direct substitution, and that will give us minus 2. But we also have to do the right side. We have only done the left side. From the right side, the function is x plus 2. So since x function is x plus 2, we can say x approaches from the right, that means the plus, x minus 2, x minus 2, and the x's cancel out, leaving you with limit x approaches 2 from the right, x, and that equals 2. So that's an example for one-sided limit. So basically a good recap would be that you change the absolute function to a piecewise function and then solve for the limits. So the last one that I will be talking about is finding a common denominator. So for instance, say we have to find the limit for this nasty little function. Say limit x plus 3. Okay, I forgot to write the limit sign, so I'll do that. Limit x approaches 6 for 1 over function is 1 plus x plus 3 minus 1 over 9 all over x minus 6. Now as you can see, this, first of all, this will equal 0, resulting in the function being approaching infinity. Also, this is kind of nasty. So if you find the common denominator for this top part, you can kind of simplify it. So let's try to do that. X approaches 6. The common denominator would be 9 minus x minus 3 all over x minus 6. But since we are multiplying this by so we have to multiply the bottom too. So this will be 9 times x plus 3. This is kind of looking ugly. So as you can see that the numerator will kind of cancel out with the denominator, because this is 6 minus x minus 6 times 9 times x plus 3. So this is the opposite of that. So if you put a negative sign at the top, you can get rid of it. So it will be minus 1, and we can get rid of the top and the bottom, the x minus 6, and we will get 9 x plus 3. Now we can use direct substitution and sub in this 6, and we will get minus 1 over 9 times 6 plus 3. The plus signs are bad, so that will give you minus 1 over 81. So hopefully this was an information session for you guys. You guys learned something, and this basically was provided to you by Academy of Higher Learning, and enjoy.